What's going on, everybody? Welcome to Learning Along 8, where we try to learn Java together. And this is a special episode because we're going to combine all the previous elements from previous videos and combine them into one big case study. And today we're going to write a program that shuffles a deck of cards. For this, we're going to need 3 separate files. And let's get started. Let's open a new project. Let's create a new project. Select Java application. Next. I'm going to call it deck of cards. But the main class that we want to create is deck of cards test. Let's finish this. So the package is called deck of cards test. So we're testing if we can shuffle a deck of cards. Let's clean up some of these comments as usual, as per tradition. And let's talk a little bit about what this program is supposed to do. We're going to have 3 classes: class card, class deck of cards, and class deck of cards test. Now, class card contains 2 string instance variables, face and suit, that will store reference to the respective name of a specific card. In class deck of cards, we will declare an instance variable array named deck of card objects in the form of private card deck, 2 brackets, and then a semicolon. So in this one, let's first create all of our files that we're going to use. We have deck of cards.java. Let's create a new file and call it, we want Java class. Next, let's call this card. Class card. Let's finish. Again, cleaning up. I'm doing everything step by step instead of skipping anything. This is going to be a thoroughly comprehensive tutorial on how to create this project because we're putting everything we've previously learned together. So now we have card, deck of cards. Now here's the interesting thing. We need to rename this because this is going to be our main class. We don't want this to be called deck of cards. Our main class is going to be called deck of cards test. So let's rename it. Either click on it twice or right click and rename, and then when you're done, press enter and then click on refactor. You're going to apply the rename components. Instead of calling it deck of cards, it's going to change it to test. Okay, and now we need to create the third and final file we'll use in this program. Again, Java class, not a main class since we already have it, and this one we'll call deck of cards. Okay. Now we have all files that we'll use, and again, just cleaning up. There's probably an option somewhere to disable automatic comments like these, and in the next video, we'll probably see how to do that. Let's start with the main class. Let's start with deck of cards test. Now, in the first line, as always, we're declaring where our package is, package deck of cards test, and you can call this anything you want. And let's do the card shuffling and dealing application here. So we're going to have public class deck of card test. We're going to execute our application with the main class. Everything looking good so far, looking very good. And let's do deck of cards, my deck of cards equals new deck of cards. This is similar to the previous programs we've written. Actually, I would say it's exactly the same as the fuel price calculator and the grade distribution format sheet that we had. Because we're going to create a constructor in this and the other files and then call on that constructor to bring forth the information when we execute this main class. Now let's do my deck of cards dot shuffle. And here we're going to place the cards in a random order. And to do this, if I remember correctly, we're going to invoke an already existing class random by importing it from the Java libraries. Now let's print all 52 cards in the order in which they're dealt. So print 52 cards in the order in which they're dealt. And for this, we'll use a for statement. for int I equals 0, I less than 13. And then we're going to post increment I 13 because 52 divided by 4 is 13. So we're going to have 13 cards per each suit. And then opening and closing brackets, as usual, get those good habits going. And we'll do, let's deal and print 4 cards. System.out.printf. Here we're going to have a little formatting. Percent 20s percent 20s percent. Let's see, how many times do we need this? 1, 2, 3, 4. Yeah, for 4 cards. You could also copy and paste this. Let's do, if you're wondering why I pressed enter just now, it's because I want everything on a new line. I don't want to have one really long line, so we can get everything on the same screen. My deck of cards dot deal card. My deck, capitalization is important, deck of cards dot deal card. And we're invoking the variables that are going to be placed into those string placeholders. All these are string placeholders, and this limits the string to a specific number of characters listed here. And we have 4 placeholders. That means we need to have 4 of these guys right here, my deck of cards dot deal card. So each time we deal a card, we're going to need to deal 4 of them, and then it's going to output it in this format here. Deck of card dot deal card. I could copy and paste this, but I'm afraid if I do that, we might get lost or confused. So I'm going in real time, typing everything character by character. We're missing a semicolon, and there it is. So we're ending our for statement. Let's end main, and let's end class deck of cards test. Test. All of these guys are going to need an S here, deck of cards. Now let's turn our attention to card.java. This is the class that will represent a playing card in our deck. So let's indicate this with a single line comment. Card class represents a playing card in the deck. Public class card. We do not need a main class because we've already declared it in a separate file. And let's do private string face. That's the face of our card. And remember in the beginning of this tutorial how we said the class card will contain 2 string instance variables, face and suit, and that they will store references to the respective name of a specific card. This is what we were talking about. They need to be private because they'll only be used here and then invoked in the main class. But here is where we store the values for, whether it's ace, deuce, hearts, diamonds. And that's going to be broken down into the face of the card and the suit of the card. And we have 52 cards per deck. That means 13 cards per suit, 4 suits. So let's do private string suit. That's the suit of our card. Now, we need to initialize the card's face and suit by creating a 2-argument constructor. The way we do this is by invoking the class public card. And now in the parentheses we're going to fill it with string card face, string card suit, opening and closing brackets. Now in some In some programs we leave these parentheses blank, but in this one we're going to initialize these variables and use them to refer to variables that we're going to write in deck of cards. So let's see what this looks like. We're going to type face equals card face, as you see here. So we're declaring this now, we're initializing it. Let's put a comment. Initialize the face of the card, and then suit equals, you guessed it, card suit. And we're initializing the suit of the card. Let's end our card constructor. And then, before we do anything else, let's do a return string representation of the card. Public string to string. We did not close our bracket. Let's close our bracket. Let's do return face plus parentheses space of space plus suit. So it's going to return, say the face is ace and the suit is clubs. It's going to return ace space of another space clubs, ace of clubs, and we'll see what that looks like when we run the program. Let's end method to string and class card. And we looks like we have an extra bracket. Let's delete that. And let's put that over here for better readability. Now this is an already existing example project that I found, but we'll make some modifications to it that I would like to see. Now we're using a deck of cards, but I would like to see a modification for maybe dice or some other simulator, and we'll do that at the end of this. Once we run this example project, then we'll modify it, and then we'll run the modified code and see what that looks like as well. Now, deck of cards, this class represents the deck of our playing cards. Here in card, this represents the actual card, the face of it, the suit of it, and it returns this message. Deck of cards test, this is our main class that once we invoke it or once we run it, it calls the constructors of the other classes and displays the information we want to. In this one, this actually represents the main deck. And to shuffle it, we're going to import the class I mentioned previously, random. So let's do that now. Import java.util.random. And we're going to get a warning message saying that unused import. We've seen this before. It's basically notifying us that we're not using our import anywhere, but we will once we get down in the code. For now, we have public class deck of cards, and we're going to initialize or declare our variables. Private card deck. This should sound familiar. In class deck of cards, we said previously that we'll declare an instance variable array named deck of card objects in the form of private card deck with the two brackets. This is what we're doing right now. This is the array of card objects. Let's see, what is it telling us for this? Cannot find symbol class private. Okay, let's keep going. Private int current card, it's an integer variable. Index of next card to be dealt. It basically keeps track of what card we're on. Private final int number of cards. Now we did something similar when we created an array last time. We created private final number of array or array final value. It was basically a generic variable that ended our array at 10. Here we're going to have the same private final variable as an integer, and we're going to limit this to a constant number of 52 cards. So we're going to initialize or set this to 52, and let's add a comment saying constant number of cards. Here's where we use a random. This is a random number generator. Okay. Constructor. The constructor is going to fill our deck of cards. Let's do public deck of cards. Remember in the last program we actually filled this. We're not filling this because we're not initializing any variables. We're just leaving this blank. Just to show you what I was talking about. And card Java, we created public card. See, public class card. And then here we have public card. We had the parentheses, and we actually filled it with string card face and string card suit, where down here we set face equal to card face and suit equals to card suit. Here in deck of cards, we're doing public card or public deck of cards, but we're not doing anything like that because we're doing string faces equals brackets ace. And this can be a little tedious because we're basically going to list everything from ace to king. Ace, deuce, 3. We need to make sure the comma is on the outside. Not the outside of the closing bracket, but the outside of the parentheses or the quotation marks. 4, 5, let's see, 6, 7, 8, 9. Now we're getting into face cards. Jack, queen, and we're almost done. King. Believe that's it. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that should be it. And now we have our suits. String suits. Let's do, there's only 4. Hearts. Diamonds are forever. Clubs. Spades. Now let's do deck equals new card. And remember that final variable we just wrote. Number of cards. And what we're doing here is creating an array of card objects. Now let's do current card and let's set that equal to 0, and then each time this program executes it's going to increment it by 1. So random numbers equals new random. Here we're initialized a random number generator. Here we're creating a random number generator that we'll use later on. Now let's populate the deck with card objects. By doing the following with using a for statement. for int count equals 0, for integer variable count, while it's equal to 0 and the count is less than the deck length, and we're going to post increment our count variable each time this executes. So while the following conditions are true, while the integer, if for example for int count 0, and while the count is less than the deck length, which is specified at 52 cards, then each time this executes, we're going to post increment our variable by 1. And we're going to do deck count equals 0. Let's scroll down a little bit so we can see. Let's do new card faces count %13 suit count divided by 13. And again, this all has to deal with the dynamics of a deck and the number of cards in a deck. Here we're ending our constructor variable. So let's end deck of cards constructor. And let's shuffle. With a one-pass algorithm. And remember from Java 2, I believe it was, where we did some theory, programming theory of what an algorithm is. Let's do public void shuffle. Void means it doesn't return anything. Let me label these before I get confused as to what they're doing. And shuffle, and this is going to end deck of cards. This one looks like it's an extra one. We'll delete it in the end. Now, after we shuffle the cards, we need to start at 0 again. To do this, we're going to initialize the current card at 0. We're reinitializing it since we initialized it already. And when we shuffle it, or as soon as we shuffle it, then we're reinitializing the card again. And then for each card, we're going to pick another random card and then swap them. And any comment that basically starts with for each card, we're going to use a for statement. So for each card, we're going to use int first equals 0. First deck.length first, and then post increment. And here we're going to select a random number between 0 and 51. Now it's between 0 and 51 because that's actually 52 numbers because we're including 0. If it was between 1, then it would have to be between 52. But including 0, we have 52 numbers within that range. And we do this by doing int second, the second pass through, equals random numbers dot next int number of cards. Remember, we initialized and then created a random number generator. Now let's swap the current card with the randomly selected card. And we do this by and we'll go over this program in detail here in a second once we finish it, iron out any errors, and see what it looks like once it runs. That way we have an idea of what's going on and what the code is doing. And think of this in literal terms. Deck first, that's the first deck, equal deck second. Deck second equals temp. Let's scroll down a little bit for readability. Let's end our for statement. But before we end the main class deal card, let's deal one card. Public card deal card. Opening and closing brackets. Before we forget, end deal card. And there it is. And to do this, we need to determine whether the card remains to be dealt. We need to make sure that the current card does not exceed the deck length of 52 cards. We do this with an if statement. If the current card is less than the deck length, then return deck current card and post increment by 1. And this returns the current card in the array. Else, return null. Return nothing. Return null to indicate that all the cards were dealt. Now let's make sure we end method deal card. And then we end deck of cards. Let's delete this. This is an extra, so let's delete this. And I like to have this on the edge here, that way I know that it fits. See how it highlights it in yellow? Alright, and now let's go over the errors that we're seeing in this program and see what's going on. Now we're playing a game of cat and mouse to see if we can find the error. They're trying to hide from us, we're trying to find them. I've made quite a few, let's see if we can spot them. I'm looking through, you know, all these error declarations, and we can read through all of them. And let's start from the top. Cannot find symbol class priv te. It looks like I misspelled the word private, missing an A. So let's see what happens if we, and a lot of the errors magically disappear. Sometimes you make a small typo and it affects a lot of code. So a lot of these, let's go back and do that again. But watch carefully now what happens if all these things pop up. So line 34, 5, and 6, it's saying cannot find symbol variable deck. Well, because it does not exist. We haven't actually declared it as anything because the code sees a syntax error as soon as it starts executing line 4. So all of these errors, instead of working from the bottom up, it's always a good idea to scroll all the way to the top and then go from line 1 down. Because sometimes you can fix a lot of errors by just a single keystroke. So let's see what else is going on. We have the array is only written to, never read from. Well, that's peculiar. That's what we're trying to do down here in this for statement. We declared it and then we're trying to read from this. So here, let's take a look at this again. It's written to. So we write aces 2, 3, 4 all the way to king in the string faces. In the string suits, we write the 4 suits in our deck of cards. And then down here in this for statement, when we populate the deck with card objects, we refer to this and retrieve this information for this. So what's going on? Well, first of all, let's take a look at 121. Incompatible types. It requires a card, but it found an integer. That's interesting. Deck count equals 0. Now, why are we setting the deck equal to 0? We want to set the deck count equal to the new card based on these criteria. So first of all, let's delete this. That's erroneous. And the error here is fixed. Let's put it on the same line for readability, because why not? Or I guess we can put it on a separate line. New card faces count %13 comma suit. Now suit cannot find the symbol, variable suit, location, class, deck of cards. It can't find it because it does not exist. See, we have faces and we have suit. We have face and suit here in the plural because, or in the singular, because we're declaring the face and the suit of one card and one card only. Same thing here, the card suit and the face suit of one card only. Down here in a deck of cards, we're dealing with 13 cards per suit, 52 cards in a deck. We're dealing with plural. And take a look here how we've declared string faces and string suits. This is highlighted in yellow and it's telling us that we're not reading from it. We're not reading from it because we're not referring to it properly. So it's missing an S. And I believe that should fix all of the errors in this program. Everything is looking very good here. Let's check card.java. We have add at override annotation. To be honest with you, I don't know what that is. Check in the description of the video for articles to see if I found anything. I don't believe that's going to affect the program. It shouldn't. And deck of cards test. So let's run it and compile it. So far, no errors. It's doing something and build successful. Total time 0 seconds. Okay, well, we know it wasn't 0 seconds, but it's working. We have 52 cards. Let's verify. We have 1, 2, 3, 4 cards in the top. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yep, 13 times 4, 52. You can verify. And we have 52 cards in a random order. Let's see. We have 8 of clubs, king of clubs, ace of diamonds, 9 of diamonds in the top, and 8 of clubs, deuce of hearts, queen of hearts. I don't see any repetitions or anything that's gone wrong. Everything looks flawless. Let's close this though and take a look at the code. Remember initially in class.java how we had return face plus of plus string. Now in a lot of the programs we write, we put public void something parentheses. Here we don't want void because void indicates this is not going to return anything. Here we're doing public string because we want it to return a string statement. The face of the card plus the intermediary of statement plus the suit of the card. As we saw when we run it again, it's pretty fun. Every time you run it, and you can see now it's been changed. So every time you run it, it's going to be different. But it's doing, let me see if I can lower that a little bit. Yes, deuce, the face, plus of, plus the suit. Now let's take a look at deck of cards test.java. This is our main class, and let's take a look at what it's doing. Declaring the package, declaring public class deck of cards. This is our main class, public static void main. It's not returning anything. Deck of cards, my deck of cards equals new deck of cards. So it's initializing it, it's calling the new deck of cards. It's shuffling it, it's calling dot shuffle. Now, if we erase a letter or something, it's going to give us an error, of course, because it's looking for this thing right here that we wrote in deck of cards.java, public void shuffle. This is where we shuffle our cards. You know, we're reinitializing the current card to 0, and this is our first deck. So integer first equals 0. If first is less than the deck length, post increment first by 1. Then select a random number between 0 and 51. Int second random numbers.next int number of cards set to 52. So each time this executes, it's creating a new set of cards, a new deck of cards shuffled randomly. And it's doing that because the main class is invoking this that we created in the other file. Now we're printing the 52 cards in the order in which they're dealt. For int I equals 0, I is less than 13, post increment I. And it's doing this because, remember, we're dealing 4 cards. So we're dealing from the top. Let's see. We're dealing 4 cards. 1, 2, 3, 4. Bam. Done. Next iteration. 1, 2, 3, 4. Bam. Done. Next iteration. And so on and so forth until we exhaust 13 separate lines of 4 cards. Here's how it works. This is why this is 13. Because we're only doing 4 cards. We have 4 placeholders and we have 4 my deck of cards. I guess if you wanted to do it the long and hard way, you could. The long and hard. If you wanted to do it that way, you could do it by column, and you could do one placeholder, 13 deep. I'm not entirely sure how to do that, and I'm not entirely sure why I would do that. This seems to be the most efficient method. We deal 4 cards in a straight line from the top, and then we go to the next iteration. So when this executes again, the program reads, and now it doesn't equal 1, now it doesn't equal 0, it equals 1. And it post increments it once it completes, sets it to 2, and so on and so forth, until it reaches, and this is not equal to, less than or equal to, it has to be less than 13. So at the 12th iteration it does it, and then it finishes. So each time it executes, let's do this, let's expand it so we see all of it, 4 cards, and so on and so forth. Less than 13 because we start from 0, so 0 to 12, that's 13 iterations. And that's about it for this program. Another thing that we covered in the very first tutorial that we had, the very first learn along, that we have not covered since, is the build package, or the distribution, the jar file that contains all of your, the Java archive file. And that's contained here under files. And we have all the previous programs we've worked on, or some of them. Let's do deck of cards. Let's expand that. Remember how we had a distribution? We had a distribution file right around here between build and MB project and SRC. We don't have one here because we're not ready to distribute this program. To do that, we need to click on the build project and do clean and build. Okay, apparently I had to actually go back to projects, close all that, not close it, but basically go back to the projects list, build it again, and then go back to files. I guess I could have, is there a refresh option? I don't think there's a refresh option. But that's what was going on. It just didn't refresh this list. Once we do that, go to the distribution folder, open it, and there is our jar file. And remember, just click on it, properties, and here under all files, select this, and it will tell you where it is. And then if you can just double click it, look at the meta files and a deck of cards test. This are your classes, and what you can do with this is email it to somebody. They also need to have Java installed in order to do this, but if they have the Java development kit, NetBeans, they can unpack it and then continue working on this project. And you can also use it to distribute it to clients. That's it for this tutorial, folks. If you have any questions or comments, please let me know. In the next version, we're going to take a look at the same program, but we're going to tweak it in ways that changes it to something different, something specific. We'll try, for example, a dice. We'll try different things. We're going to customize it to fit our needs wherever they may be. We're going to use the import.util.random and set some variables, and we'll see how we can play around with this program to achieve different goals. Thanks for watching, and I'll see you next time on our Ecology Designs production. What's going on, everybody? Boris here at the Ecology Design Studio. In this video, I want to